All right, here's a couple of questions. One transformation question, another exponential equation one. Okay, so for this first question, I'm actually not sure what the whole question is. But when I take a look at it, I can see some transformations there. First off, there's this inside the brackets there, so it's a C thing. So as it said here, the thing goes to the left one, and that's correct. And then it flips to the other side. That's correct because of the minus sign there. So it flips to the other side. And then the 2 will vertically stretch the graph. Okay, or in other words, you multiply all the y values by 2. Actually, since there's a minus in front, you'd multiply them all by a negative 2. Okay, so if they're asking what are the transformations, that's all you'd say. Left 1, flip, stretch by a factor of 2. Now, if they say they give you a point, so they could give you a point. So they say on the graph of whatever, I have a point of -2 and 1. Say that's my point. So if they say, what will the new point be given these transformations here, then I'd have to change these. So first off, if I move to the left 1, that'll change the x value. And if I flip and stretch, that'll change my y value. So I can do all of that at the same time if you want, or I can do it in stages. Maybe let's just deal with the x first. So if I move to the left 1, if I'm already at -2, if I'm here, if I move left 1, I'm going to be at -3. So that'll be my new x point. Okay, now the y, what I need to do with the y value, this 1, is I'm going to need to multiply all y values by -2. So 1 times -2, maybe I'll put an arrow there. So I have to multiply this by -2. 1 times -2 would be -2. So if they say this is your original point, transform it according to that, this here would be my new point. Sometimes they actually ask you to transform a number of different points. So they could give you that point -2 and 1. That'd be this point right there. And maybe they give me another point here, another point here, and a last point there. So then what I need to do is do that same thing. Move things left 1 and multiply the y value by -2. And I'd have to do that for this point, this point, this point, and this point to find my new points. Okay, so that's a transformation question. Here is a radioactive isotope. It says have a half-life of 1450 years. How many years would be required for given to decay to 80% of that amount? So this is a two-step question. First thing, they tell me I have a half-life of something. Okay, so that means that I maybe start with 100, and if it's half-life, that means how long does it take to get half of that? So half of that would be 50. So 100 would be my P0, that's my starting amount, and then my ending amount would be this P of T, or 50. Now, let's just maybe write down our whole formula. So P of T is equal to P0 e to the KT. Okay, so if they say my half-life is 1450, they're actually giving me a first number, so I could put it as 100. You can use any number there as long as what it winds up with is half of that amount. So this radioactive isotope might start at 100, it'll end at 50, and it does that in 1450 years. Okay, so that's my time, and there's my K, and my K is what I'm going to try and solve for this equation. So first thing, divide by 100, divide by 100. So I get 0.5 on this side is equal to E to the K times 1450. Change to log form. K times 1450 is equal to log base E of 0.5. And then divide both sides by 1450, divide 1450, so I get K is equal to, let me do that on my calculator. Okay, cancel that. So I have to go ln of 0.5, ln 0.5, divide 1450. Okay, so I'm getting negative 0.000478 and other stuff after that. So that's my K value. So that's my first part of the question, is to solve K. So if I wanted to write this decay function, it'd be P of T equals P0, that's, well, I guess I don't know, P0 e to the K, my K is negative 0.000478 times T. That's my K value. Okay, then they say, how long would it take for this given amount to decay to 80%? So in this case, I'm going to start at 100%, but I'm not decaying to 50, I'm decaying just to 80% of that. So the time should be a lot less than 1450 years, because that's how long it takes you to get all the way to 50. If I'm only going to 80%, it should take less than 1450 years. Okay, 80 equals 100 e to the negative 0.00478 t. I have an equation where I know everything except for t. So first thing I'll do is I'll divide this side by 100, this side by 100. So I'll get 0.8 equals e negative 0.000478. I think I missed a 0 on this one. T. Change the log form, negative 0.000478t is equal to log base e of 0.8. So ln of 0.8 divided by negative 0.000478, you can do that on your calculator, and that's going to tell you how long it takes that radioactive isotope to go from 100% down to 80. Okay, hopefully those will help you on those questions. Good ones.